Welcome to part 2 of the white LED versus the red-blue LED grow test. So in this video, I'm just going to show you the growing of the plants underneath these lights, not so much the science and education behind it. If you want to know the science and education, check out part 1. It's a long video, but there's a lot of information to know about this, and it's in the link below. So if you're researching this type of stuff, if you're looking for videos like this, this is a very common question, and you probably already know what's going on with this, so you don't need to check out the video. But if you do, it's in the link below. So anyways, the lights, I'm going to talk about that first. They're both identical lights. Physically, they're identical. The only difference is the wattage consumption and the chip. They're both chip on board LED, and they're about that big. The difference between the chips, this one here has it's 10 blue diodes, 40 red diodes, and this one here is just a white chip. And as I said in the last video, white LEDs are basically blue LEDs with a phosphor coating. This one here is a 3000 K color temperature. In the last video I talked about the light, it was 6000 Kelvin. I said it was 5500, I was wrong. I made a mistake. I apologize for that. That one is too much, it's too heavy on the blue side. So it is a white LED, but I want to do a proper comparison. So 3000 K is heavier on the red spectrum than the blue spectrum. So in order to compare it to this light, I wanted it to be as close as possible. As far as like the intensities go, I was talking about that a little bit in the last video. Because of the wattage difference, you're going to have different results when they're at the same height, because the 50 watt here, the 50 watt it's consuming is spread among those different spectrums. So I don't know how much, and that's kind of the reason why we're doing the test. But some of that is going into the green and yellow spectrum, and some of that's going to the red and blue spectrum. So the intensity of those red and blue are going to be different than the one over here, the red and blue LED, because this one's putting 38 watts, pulling 38 watts from the wall, but it's putting all that energy into those two spectrums only. So the first grow test is going to be both of these lights at the same height. The second test is going to be with a power meter. I'm going to move the light, one of the lights up or down, below or above the other, to get the same micromole reading on the meter. I want to make sure that the intensity is the same reaching the plant. I think that these two lights here are the best comparison. Now I know that they're not intense, but I'm going to talk about that in a second here. The plants I chose to grow under these lights is cherry tomatoes. And the reason why I chose cherry tomatoes is because it's a flowering and fruiting plant, and it grows tall. So the biggest thing about that is while they're not going to grow to full term under these lights, I mean I probably could grow them pretty big, you know, maybe about this high or so, but they're not going to finish with it, be a big plant or anything like that, because these lights here just aren't going to be intense enough to do that. They'll still grow, and I'll probably get some results out of there, and that's the whole idea. It doesn't have to be the biggest plant to be able to get a result. So the red light doesn't penetrate the canopy as well as blue light, but green light penetrates the canopy the best, which means it gets down to the lower chloroplasts of the plant. And that usually would mean that you get more bigger, fuller leaves deep down in the canopy in the lower parts, to where this one over here, in theory, because it's heavy on the red spectrum, isn't going to get as much light down, even though technically is probably more intense at the same distance as this one with those two spectrums. So the lower leaves aren't going to get as much light. In order for a plant to flower and fruit or go into the flower or fruiting mode, you actually need to tone back the blue light, because blue light actually inhibits the production of auxin, which is a chemical that drives that process. So it's a common misconception that you say, I need to give it more red light. You actually need to give it less blue light. More light is not bad, though. It's actually better because you want more intensity. So no one's really wrong in that matter. So we're going to go ahead and grow these plants, 4 plants under each light, and we'll see what kind of result we get from that. That's pretty much it. I did want to comment a little bit on green lights, though. I mentioned in the last video about how green lights, I don't have a grow room, but I have a grow box. But what I know about green lights is that they're used for, if you want to go in your grow tent, grow box, grow room, whatever, and you want to tend to your plants at night without disturbing their 12-hour night cycle, on an uninterrupted night cycle. If you get a party bulb that's green, or if you get a plant bulb that's green that's meant for that, and it's fluorescent, fluorescent light, even though it's putting out green light that you can see, they actually are putting out different spectrums, so like blue and red. There's little spikes in there too, and if they're close enough to the plants, it can actually disturb their night cycle, which would inhibit some flowering and fruiting growth, and it might start driving more vegetative growth. It's probably not going to do it a whole lot. It really depends on the intensity of it. For the most part, they're going to work just fine, but if you're trying to make it really bright, the best thing to do is get a green LED, because green LEDs put out just green light in a single spectrum. There's no other light spectrums mixed in with that. So you can make it as bright as you want, and it's basically invisible to the plants. I know I said that green light is necessary for the plant to grow. It's to aid in the growth process, but it cannot grow with that alone. But it's not necessarily getting green light from a peak in just like 530 nanometers or whatever. It's getting shades of green, and it's at a certain green. I don't know what it is offhand, but at a certain part of the green spectrum, everything pretty much tapers off to nil, to nothing. So don't get confused with that, because every type of light, every type of color you see has shades of it, and for plants, the particular shade of that light, the particular peak in a certain part of the spectrum, even though it's not visibly different to the human eye, it is very different to the plant. That's pretty much it. I hope you enjoyed the video, and I hope you learned something from it, and I'll be looking forward to it myself to see what this looks like when it's done. And we are back. Finally, after I don't know how long it's been since I started growing these tomato plants underneath the 2 different LED lights, but they're finally done growing, at least for the experiment anyways. I got the data that I needed, and I wanted to show it to you. Before I get into talking about it, I want you to guess on which set of 4 here and here were growing under which light. Okay, I'm just going to tell you. The bundle here, this was grown under the red-blue light, and this was grown under the white light. Immediately you can see the difference in the plants. These here have all collapsed under their own weight, and these here are standing straight up. They're leaning against the wall a little bit, but don't worry about that. They're standing straight up. Feeling the stems that were underneath the red-blue light, they're soft, they feel rubbery. Even the thick one here. The stems underneath that were growing underneath the white light are a lot more rigid. They feel kind of like, a tree branch. Not woody, but just rigid like a tree branch. And even the thin ones here, the thin stems, these are just as hard as the bigger ones. The other thing you can notice here is you probably can't see it on the video, but I can see it. The stems were a lot fatter underneath the white light versus the red blue. These were generally all thinner on average. That's the very first thing I noticed. And in the beginning, there wasn't really much of a difference. They grew both pretty much equally, neck and neck in height. There was not any reaching going on. I checked the nodal spacing. It measured 2.5 inches on average between both of the sets of plants, so that was okay. Until it got to the certain point through the adult stage where the plants underneath the red-blue light collapsed underneath their own weight. They couldn't even grow, probably another couple inches before they started, falling down, collapsing on themselves to where underneath the white light, these just kept on growing. That was one of the very first things that I noticed as far as differences go. The leaf structure, looking at the leaves here, the leaves underneath the red-blue light feel a little bit thinner. They don't look as healthy if you look closely at them. To the average person, you probably wouldn't see it, but unless you feel them and look very closely, that's when you're going to know. Yeah, underneath the red-blue is definitely more of a flimsy leaf and thinner, to where the white ones, they feel a little more rigid and thicker, and just generally look healthier. So that's the other thing as far as, you know, feeling them goes, to get some kind of data out of that. As far as the fruit goes, they both produce exactly 9 cherry tomatoes, and they're green, but they're not going to have a chance to ripen, and that's due to some scheduling issues going on here. But I had to kind of stop this experiment where it was at, and I'm going to let them ripen on their own off the vine. Anyways, they both grew 9, and I have them right here, and between both of these, they pretty much look the same. The size of them on average are about the same, so there's no differences. I'm going to let somebody else taste them after they ripen, because I hate tomatoes, but yeah, I'm going to let someone else do that. So the other thing I wanted to mention was, in the last video I talked about the how red light doesn't penetrate the canopy as well as blue light. So if you have a red dominant light, such as the one I used here, the leaves are green, and the green leaf will filter the light. So as it goes deeper and down into the canopy, there's less light actually reaching the bottom, less intensity, to where, you know, blue light is going to penetrate it better. And then you have even green light, which is part of the white spectrum. Green light will then penetrate down, and that's going to reach the lower chloroplast and everything. And you can see that visually on these plants. If I'm looking right here, you have a sucker, or you can call it a branch, but you know, these are called suckers on tomato plants. That's just the name they give them. It's just at the node you have a branch, and then you have another branch that starts growing in between it. If you top the plant here, or cut the stem off, the main stem, that more light will reach this, and that will trigger it to grow. At about 12 inches height, the suckers on the red-blue LED light, they didn't grow at all. They didn't grow any bigger than what you're looking at here on pretty much every single stem here. On the white LED light, there's a sucker right here that started growing about the same 12-inch mark. It's a branch that grew all the way up. And the same thing for the rest of them. All the suckers, the branches, were growing up from the lower parts of the plant, so that light is penetrating the canopy. It is a night and day difference between these, and that's kind of what I want to do with this experiment. So I wanted to talk about the pictures, because I took daily photos, so I'm going to get into those right now. So what you're looking at here is the seedling stage, and I didn't have a divider to begin with, because I wanted to see if the seedlings would favor one light towards the other. Because seedlings, when they emerge from the soil, they will immediately start leaning towards any light source, and that is the best time to see if the plant is favoring one light or the other. So just through the seedling part, I had a middle row that were both on the edges of the lights, and then 2 outer rows which were much further away. So the middle row was getting a mix of both different lights, and the outer rows were getting pretty much no light from the other light, maybe just a little bit. And there was really no results from that were conclusive. They were leaning a little bit towards one or the other, but there wasn't any thing to say one plant is favoring one light or the other, because some are leaning one way, some are leaning another way. It didn't really make any sense. So I think it was just the natural part of the growth, and they were just saying, hey, I'm going to lean this way, I'm going to lean that way, whatever. So through the adult stage, you know, they grew neck and neck up until they got to a certain point. Like I said, the red-blue light plants, they collapsed under their own weight. I had to stake them up, and I never had to stake up the white LED light plants. They grew rigid, and they grew straight up. They did not fall over. Actually, I think the 2 plants towards the back on those, they leaned over a little bit, but they continued on growing up. The red-blue ones, they stayed on the ground, tried growing up, then they would collapse down again, try growing up, collapse down. It just never worked. So, you know, that's kind of my comment on that. Tomato plants need to be pollinated, so That's the kind of the weird thing, is that I had a fan blowing in there, and wind isn't really going to work too well for pollination. At least not as well as an insect can pollinate, because insects will directly pollinate flowers to a wind that you're just basically chancing it. I had fungal gnats. Fungal gnats are a huge part of growing things inside the house. And a lot of people have them. They're hard to get rid of, but in this case, they worked out pretty well for me, because I think the fungal gnats, since they are attracted to yellow, I think that they are responsible for some pollination, and that's why I got some cherry tomatoes out of there. I was too lazy to pollinate them myself. So let me look at my notes here real quick. I'm not sure if I covered everything here. In the last video, I was talking about how you can just grow plants under just red and blue light alone. That is absolutely true. You absolutely can grow under just those two wavelengths of light. However, like I said, you will get a better result under a full spectrum light, in this case the white LED. So it doesn't really answer the question to some people, because they're probably thinking, oh, you can get advanced LED, platinum LED, black dog, kind LED. I mean, there's all different kind of manufacturers that will just make an array of, that you get that pink purple light, and they'll make an array of different color LEDs to try to create that perfect spectrum to grow plants. And my comment on that is, why try to create the perfect spectrum when you can just use white light? White light is a full spectrum light. Depending on the color temperature, there's some variance in there, but why not just replicate the sun? Or if you're talking about efficiency, the red LEDs are the least efficient. I don't know, I wouldn't say they're the least efficient, but red LEDs are very inefficient as far as energy consumed versus light output and intensity. Even though the plants use a lot of red light, it's just not that efficient as a white LED, because a white LED is a blue LED with a phosphor coating. It's basically just fluorescent light. And I'm going to talk about that here in a second, actually. But blue LEDs are more efficient than red LEDs. They're actually very efficient in energy consumed versus light output. And then the next step up from that would be green LEDs, but you can't use green light to grow plants alone, so that's just out of the question. And you're not going to make a white light out of a green LED anyway. So when I talk about the blue light, I commented on this 2 times before, I think. Blue light is, when it's deep blue, is very similar to like a black light. So if you use a fluorescent marker underneath the black light, it looks like it glows. It's pretty much going to do the same thing under a deep blue light. Maybe not quite as much, but it'll still do the same thing. So if you think about how a fluorescent light works, like a tube fluorescent, like a T12, T8, whatever, it has a phosphor coating on the inside of that glass, which is why it's white. That's the phosphor coating. If you take that phosphor coating off there, if you wipe it off if you can, on the inside of that, you're going to have a clear glass, and all you're going to see is it's going to be like a blue light. It's going to look just like a germicidal bulb, because technically it's UV light. And the only difference between that and a UV and a germicidal light is just quartz glass. I'm not going to get into that though. So you're not going to well, I'm going to talk a little bit about that. If you wipe off the phosphor coating on a fluorescent tube, it's not going to be dangerous or as dangerous as a germicidal lamp, because the UV doesn't pass through the glass. Certain parts of it, but not so much the dangerous stuff. The dangerous stuff is more absorbed, and the germicidal lamp is quartz, and it passes through the quartz. So UVC light, and that would give you like a sunburn, it'd be bad for your eyes, stuff like that. Okay, so a little sidetrack there, but anyways, a blue LED, they put the phosphor coating right on the diode itself, and that causes it to glow. It's actually fluorescing, and it's creating that white light. There's also something called remote phosphor, which is basically like certain lights and certain things will have a disc that sits like above or outside of the diode, the blue diode, and it just fluoresces like that, to where other ones is right on the diode. And the reason they do that is for heat buildup. But mainly, if you think about it, technically a white LED is technically a fluorescent light because you're causing the phosphorus to fluoresce, and it's no different than a fluorescent tube light, glass light. There is no such thing as a white LED, and that's how you create the white light, is through the fluorescence. So it's because it's causing it to fluoresce. Now, I probably talked a little too much about that there. I'll just go over my notes here. I want to make sure I don't forget anything for you guys. Oh yeah, the other thing I want to mention was about the other lights that you use, like the pink purple lights that you can buy that are really expensive. They do work very well for growing plants. This experiment was just about growing under just those two wavelengths, just red and blue. And most of the time, if you're looking to buy a panel, it's not going to have just red and blue. It's going to have the other colors of LEDs, the other wavelengths of light, different, to create that perfect spectrum. So if you're yelling at me out there, that's what the difference is here, is just talking about, can you grow lights under just those two wavelengths, and that's it. So that's pretty much it. On a more personal note, I just wanted to say that, the reason I do these videos is because I like to. It's a hobby of I like doing experiments, and I like sharing the information. I don't do it for subscribers or views or fame or money, nothing like that. I simply like doing it. But if you do like or subscribe, it really does help me out, because it gives me motive to keep doing this kind of stuff and to share the information with you. And I know this is a very hot topic, and I know there's a lot of people that probably could benefit a lot from this information. So as far as the lights go, I would say use white LEDs. Chip on board will not work quite as well as an array of smaller white LEDs, but they work very well for a budget. If you want to use red-blue light, there's nothing wrong with adding that to your white light. But typically you're going to use that for flower or fruiting. So that's about it. I hope you liked the video, and like I said, I'm sorry the video is too long, but there's a lot of information to cover, so I appreciate you sticking around this long to watch the video, and we'll see you in the next video.